All right, this is just a quick little review lesson of some of the topics that we did in class. Want to review what happens in the reflection of waves in strings. So here we have a picture of a string, and there's a wave coming towards this rigid barrier. And we want to know what happens when it hits this rigid barrier afterwards. And then also over here we have the same kind of wave approaching, but now there's a little ring attached to this rod, and so this ring can move up and down, and so this would be called a free end reflection. So it's not a fixed end, it's a free end. So we'd like to know what happens to the wave on the other side. So let me show you an animation for that. So this is a little virtual physics lab from FET, the University of Colorado, and we have a string here attached to a fixed end, or we can change it to a loose end or no end. We can either manually move this with this wrench and make a wave. We can oscillate it like that. So there's a lot of things that we can do. And we could also pause it in time, as you can see that. So what we want to do is examine what would happen if we were to say, let's go to manual here right now and change this to, we'll restart this and make this a fixed end here. And we're going to send one single pulse here. So I send a single pulse right here. I'll pause it. And what's going to happen when it hits this rigid barrier? Well, you have to think about, well, these little beads, when they hit this end, there's going to push in one direction on the wrench here, or this clamp, and the clamp is going to push in the opposite direction. Think of Newton's third law. Every action has an equal and opposite reaction force. So as I play here, you can see it comes back reflected to the other side. And you can see it's actually kind of decreasing in size, and that's because of the dampening that I have here. If I were to, let's say, restart this and reduce the dampening to 0, and then send the pulse through here, you can see over time it's just going to continue to have exactly the same shape. The dampening here just basically loses the energy as it moves from one place to another, and it decreases in amplitude. So the fixed end reflection, you can see, if I send it, it comes back with a phase change of 180 degrees. It flips over to the other side. If I now change this to a loose end, where you have this ring here where this can move back and forth, now there's no barrier for you to have Newton's third law, where every action has an equal and opposite reaction force. So this can move freely up and down. So what do you think happens here? So as this wave approaches here, what's going to happen when it hits this barrier? Well, it comes back exactly the same side. So there's no phase change, as we call it. Okay, let's go back to our notes now. Okay, so that pulse that was coming through here, hitting the rigid barrier, is going to come back something like this. All right, you can notice that front end here is right over here now. I didn't do a really good job. It's moving back. So the pulse, well, it basically flips as it comes back. So it goes through a phase change here of 180 degrees. Or you could say it inverts itself. Inverts over as it comes back and reflects the other side. Now with the free end here, what you see here is that the string goes along here like this and moving to this direction, but there's no phase change, so without an inversion basically. So there's no inversion or no flipping. Okay, now looking down lower in your notes, you'll see that we talk about, now a very similar concept can be applied when we talk about a heavy, more dense rope that comes into a lighter rope. And then a light rope coming into a more dense rope. Now this is very similar to what we were just talking about, because if you think about it, the rigid barrier is something really heavier. And so this light rope coming towards the rigid barrier, you get two things that happen. First of all, the light rope will have a reflection at this barrier here, and there will be a reflection. It'll invert itself because this is a more rigid barrier than the medium where the wave was coming from. And then over here, you'll get a bit of that wave being also transmitted into the new medium, the new heavy rope over here. So you can see this is your wave that is being transmitted through, and this is the wave that's being reflected back. Now over in the situation, when you go from a more dense to a less dense medium, well, you never ever really get any kind of inversion that occurs in a transmission. So it's always going to continue in the same side here. However, When it reflects from the more dense to the less dense, there is no phase change here. So you can see it stays on the same side because this is essentially like a free end reflection, and this is like a fixed end reflection. We're going to be using this principle later on, particularly when we talk about something later on about thin film interference. Okay, so just keep that in mind later on when we talk about light, because that's going to be important, this concept in that area. Okay, and that's it for this little mini lesson about reflection in strings, so that you understand what happens with a fixed barrier and a free end. So fixed barriers have a phase change of 180 degrees, and free end has no phase change at all. Okay, and that's it.